Hey all, my name is Tyler Wilson, and today I want to talk about learning in physics and mathematics and how you can possibly abstract your work if you haven't already. So let's imagine something. You as a student are taking a physics class that involves the use of algebra, and so far you've just gone through high school and have ended up here with your current skills in that set of mathematics. There are many people who learn algebra in a specific way that isn't necessarily incorrect, but it will keep you from being able to fully appreciate and understand the meaning of the mathematics that lays before you. Simply put, most people do not represent mathematics symbolically. What do I mean by this? Well, imagine you have a problem where you're working with vectors to find a solution to some kinematic motion. It's almost intuitive for most of you to list the components of those vectors as numbers and to work directly with those instead. Heck, if those vectors are just integers, then that is probably faster to work with than representing them symbolically. But this is bad practice. If you were to represent the mathematics in front of you symbolically, you could do something like denoting the x and y dimensions of a velocity vector like vx and vy instead. Let me tell you why I think doing mathematics like this is better with a couple of strong arguments. For one, working in numbers is slower than working symbolically. When adding, subtracting, multiplying, and dividing numbers during an algebra problem, it can be very easy to waste a lot of time during something like an exam on steps that could have been combined in one go. Naturally, when you see two numbers that you know can be subtracted with each other, you might want to go ahead and plug that number into a calculator in order to simplify it down to one term. However, in the next step to solve the problem, you realize that you need to divide that number, and once again, you have to plug those numbers into a calculator. Do this 5 or 6 times, and you could have wasted up to 1 to 2 minutes on a single problem just plugging in numbers. This also has an unintended consequence, in which the more arithmetic that you do in a calculator, the more you will round and inevitably stray away from the exact answer. Try it. Multiply 0.66 by 2,453, and then multiply 2/3 by that same number, and you get a difference of 16.33. That's a 1% error in your calculation that was completely unnecessary. Though I doubt you would lose any points over this in something like an exam, it can certainly happen, and it's also not good practice for the precision that physicists are so often trying to achieve in their research. We can also argue the fact that through doing math symbolically, we can cancel out terms to save time. I can't think of a better example than that of an object in freefall. Using Newton's second law of motion, F equals ma, and also knowing that the gravitational force near Earth is mg, we see without any real calculation that the mass terms must cancel out, and regardless of the mass, an object in freefall has to accelerate at the rate of g. Number 2. Symbolic representation enhances your understanding of math and physics. Make no mistake, mathematics is difficult. You are often working with ideas that are quite abstract when they are first introduced to you. However, by learning to work with mathematics symbolically more often, you can reduce some of the mental effort that goes into understanding something, and with time, you can discuss concepts that are essentially impossible to discuss unless we go through that pesky abstraction. Let's take the ideas of dimensions. You are probably used to discussing geometric objects like circles and spheres, but they are just but a fraction of the possible geometric objects that carry this radial symmetry. Sure, we are used to discussing that circles have 2 dimensions and spheres have 3 dimensions, but what if I need to understand a shape that has 1,000 dimensions, or even a few million dimensions for that matter? Well, once we get to the tiny number of 4 dimensions, our real-world experiences break down and we can no longer use our intuition to solve these problems. But the symbolic nature of mathematics can help us. By abstracting our dimensions to some arbitrary value n, which doesn't even have to be an integer by the way, we can learn more about the general properties of all possible shapes that carry our previously discussed radial symmetry, and then we can use that information to solve many problems. Just recently, I learned to find the entropy of an ideal gas from first principles. Part of solving that problem requires creating a factor that maps out the surface area of a momentum hypersphere that carries 3 times the number of particles of dimensions. Let me repeat that. To find the entropy of a mole of an ideal gas, we must calculate the surface area of a sphere-like object with 30 to the 22 dimensions. If that isn't an abstraction that is impossible without symbolic mathematics, I don't know what is. So, next time you work on a physics problem, think to yourself, what math must I go through so I have to make as few computations as possible? How can I use symbolic mathematics to understand the relationships between my variables in a way that isn't possible with simple numbers? Is there a way to abstract the relationships I'm working out so that I can understand this concept better? With that mindset, the world of mathematics is your oyster.